I'm starting with a dataset. Think of it like a spreadsheet. This one has information organized into rows, samples, and columns, features. This is a special scikit-learn tool. I use it to process my data. The important part is that it maintains a one-to-one relationship between the input and output features. It's like a super efficient copy machine. It makes an exact copy of each feature and does not add or remove any. It's all about preserving the original information. These are the names of the different pieces of information in each row of my dataset. I have 3 features, A, B, and C. Imagine these as different columns in a spreadsheet. Now, I'm ready to test your understanding. After I apply the OneToOneFeatureMixin, which statement accurately describes the transformed data? This is incorrect, because the transformation keeps the same number of features. This is the correct answer. The OneToOneFeatureMixin does not add or remove any features. This is incorrect. I'm not losing any information during this transformation. This is also incorrect. The number of rows, samples, remains the same. Only the features are being processed, not rows. This is what I get after I apply the OneToOneFeatureMixin to the input dataset. Since it's a one-to-one transformation, the output will have exactly the same features as the input. I am using a scikit-learn transformer, a tool for data processing, which utilizes the OneToOneFeatureMixin. That is, it maintains a one-to-one mapping of input features to output features. It's like a mirror. What goes in comes out exactly the same. This is the question we need to answer. It asks about the output of a scikit-learn transformer using the OneToOneFeatureMixin. I'll break down each option. This sets the stage. We're assessing the impact of the OneToOneFeatureMixin on the number of features and samples in the dataset after transformation. This option is incorrect because OneToOneFeatureMixin maintains a one-to-one correspondence. It doesn't add features. This is the correct answer. The OneToOneFeatureMixin ensures that the number of input features and output features is identical. This is incorrect. OneToOneFeatureMixin does not remove features. It only transforms them, maintaining the original count. This option is also false. OneToOneFeatureMixin deals only with features, not with the number of data points, samples, in the dataset. It doesn't change the number of rows. I'm starting with a dataset. Think of it like a spreadsheet, and each row represents a single observation or data point. Each column represents a feature, or characteristic, of that observation. In this case, I have features I labeled A, B, and C. I'm using a special tool from the scikit-learn library, called OneToOneFeatureMixin. It's a special instruction that ensures a one-to-one relationship between the input features and the output features. This means, no features are added, and no features are removed. It simply keeps things as they are. My input dataset has 3 features, which I creatively named A, B, and C. Think of these as different aspects of the data I'm analyzing. After applying the OneToOneFeatureMixin transformation, I'll get a new dataset. Since the transformation doesn't change the features, the output will still have the same features A, B, and C. It's like a carbon copy, but the super important part is, it's going to preserve the one-to-one mapping. This is wrong because OneToOneFeatureMixin doesn't add features. The number of features stays the same. This is correct. The OneToOneFeatureMixin ensures that, and that's what we've just worked through. This is also incorrect. OneToOneFeatureMixin doesn't remove features. This is false. OneToOneFeatureMixin focuses only on features, leaving the number of samples untouched. I'm starting with a dataset. Think of it like a spreadsheet with rows for each data point and columns for different features. In this case, I have features labeled A, B, and C. I'll be using a special scikit-learn tool called OneToOneFeatureMixin. Think of this as a filter that guarantees one output for every input feature. It's a one-to-one match. It doesn't change the number of data points, rows, only the features, columns. These are the names of the columns in my input dataset. We can think of them like different characteristics we have measured from our data points. For example, A might represent height, B, weight, and C, age. I'm asking you to identify which of the statements correctly describe what happens when you use the OneToOneFeatureMixin on my dataset. This option suggests the transformer adds features. That's incorrect because the OneToOneFeatureMixin only maps input features to output features. A one-to-one mapping. This option is correct. Because of that one-to-one relationship, I will have the same number of features after applying the transformer. This option wrongly claims the transformer removes features. Again, the OneToOneFeatureMixin keeps all features. This option is also incorrect. The OneToOneFeatureMixin only works on features. The number of samples, rows, remains unchanged. After applying the transformer, I will still have the same number of data points. Only features, A, B, and C, will remain exactly the same. These are the features in the output after applying the OneToOneFeatureMixin transformer. I'm looking at a scikit-learn transformer that uses the OneToOneFeatureMixin. This mixin is a key part of the problem. It's like a special instruction that tells the transformer to maintain a strict one-to-one relationship between input and output features. This is the core action we are examining. The OneToOneFeatureMixin will transform the data. I'm emphasizing that this transformation doesn't change the number of features. It just ensures each input feature maps to exactly one output feature. It's like shuffling a deck of cards. The number of cards remains the same. I have data with features A, B, and C. Think of these as different characteristics of the data points, like height, weight, and age for people. This is the question that drives this entire problem. I need to understand how the OneToOneFeatureMixin affects the output features and the number of data points, samples. After the transformation, what will my data look like? This is the crux of our analysis. Because of the OneToOneFeatureMixin, the number of features will not change. The output will still have these three features. Remember, the mixin doesn't remove or add features. It's simply a one-to-one mapping, like a perfect mirror image. This is the correct answer. Because of the OneToOneFeatureMixin, the number of features in the output is identical to the number of features in the input. It's a perfect match. The number of data points, or samples, stays the same. The OneToOneFeatureMixin only works on the features themselves, not the amount of data. I'm starting with a dataset. Think of it like a spreadsheet. Each column represents a feature, like A, B, and C. Each row is a sample. This is what we'll feed into our transformer. I've got three features, A, B, and C. These could be anything, height, weight, age, or any other characteristics of my data. These are the columns in my spreadsheet. I'm using a special scikit-learn tool called OneToOneFeatureMixin. It's a transformer, and it's crucial here that it's a one-to-one feature transformer. This means it ensures that every feature entering the transformer gets exactly one and only one corresponding feature at the output. It neither adds nor subtracts features. This is the result after applying the OneToOneFeatureMixin to my input dataset. Let's see what changes, or doesn't change. Because of the OneToOneFeatureMixin magic, my output also has three features, A, B, and C. Exactly the same as the input. No extra features, no missing features. This is the question. I have to analyze the output of the OneToOneFeatureMixin transformer and choose the one statement which is most correct. This is the correct answer, because, as we've seen, the OneToOneFeatureMixin preserves the number of features. I'm starting with a dataset. Think of it like a spreadsheet where each row represents a data point, like a customer or a product, and each column represents a feature, like age, income, or price. This specific dataset has features labeled A, B, and C. These are the names of the three features in my input dataset. I'll use them to explain this concept. This is a special process from the scikit-learn library that I use to change my data. It's called OneToOneFeatureMixin. The important thing to remember is this process keeps the same number of features that I start with. It's like a filter, it doesn't add or remove anything. This is the question. I'm asking you to tell me what will happen to the features after I use my special transformation process. After I apply the OneToOneFeatureMixin transformation, this is what my dataset looks like. The key here is that the number of features will remain unchanged. Hey Vamsi, I'm using a tool from the Sklearn library, a very popular Python library for machine learning. This tool, which uses the OneToOneFeatureMixin, is like a special function that modifies my dataset. The magic is that it guarantees a one-to-one mapping between the features I start with and the features I end up with.